title of this course is Research Methods for Engineers, right?
Yeah.
So, as I was telling, this course is part of the 3 series. So, with this term, you are going to come out with your research problem. You are going to tell, yeah, I am going to work on this problem. I have these objectives, okay? And this is the knowledge I gained on this topic. I did some literature review. So, literature review means you go through the scientific journals, technical journals, and any information related to your particular topic, your chosen objectives. Okay? So then you will say that, okay, I want to do this, I want to do this. So you come out with a brief methodology. So you are going to apply what all you studied in the course, okay, to solve this problem. So the problem must have objectives. Okay, so you need to have clear objectives. Then you are going to do background knowledge, background analysis of the problem. So you need to do all the background analysis of the problem. After that, then you need to tell, okay, I'm going to apply this methodology. Depending on your problem, you can say, I have this idea. And you also come out with an action plan. Because for any engineering problem analysis or problem solution, you need to have a plan, right? So what is the plan? So plan means you're going to tell, okay, your project A will be 13 weeks. So project B will be 13 weeks. So you have 26 weeks of time. So you are going to tell out of this project A 13 weeks. So week 1 to 4 I'm going to do this part of my project. Then week 5 to 8 I'm going to do these things. So you are going to subdivide your problem into smaller manageable parts. And you are going to plan, okay, this is how I'm going to solve this as part A. So part A of your next term project work, okay, and part B. So that is the culmination of your project work. So this term you are going to just come out. So looks everything new. Okay, so you are going to come out with an action plan. So all those things you need to put forward at the end of this term. So you are going to come out with a research proposal. Okay, so there are different ways we can assess this course. So there are, you must have seen the camera slide, there are 4 parts. What are the 4 parts? What is the first part? So the first part you are going to come out with some 3-4 pages document. You are going to tell, okay, this is my problem. So these are my objectives. So this is the background analysis of my problem. Then after that, so you have, what is the weightage for that? 20%? So you have 20% weightage for coming out with identifying your research problem and coming out with the background analysis of the problem and objectives of the problem. Okay, after that you are going to come out with another document known as the literature review. So part B of your assessment is literature review. So literature review is where you are going to go to the library. So how do you go to the library? Almighty online resources. So you can log into your Almighty library. So there are umpteen number of journals. Okay. So you know how you can go deeper. Okay. So you have different types of journals. Okay. So there will be a query-based search engine. So you can give queries, then you can identify. So what is the latest knowledge available related to your particular topic? So you're going to use extensively the RMIT online resources, particularly the library resources. So that's how you're going to do a literature review. So that means you are going to study and understand and write a short review on the problem which you have chosen and the state of knowledge related to the problem. So that will be, so again, another 7-8 pages or 10 pages you write down on the problem, the literature review. Okay, there is a particular way of writing, so we can talk about that later. So that is the second part. So you have 20 marks plus 30 marks, 50 marks. So then you need to submit your research proposal. Okay, so the research proposal will have 40% weightage. After that, there is a 10% weightage for oral presentations. So you will have your online oral presentations for this. Okay, so there are 4 components. First, the research problem, then literature review, then coming out with your final research proposal, then you need to defend your your research proposal. Okay, so that will be the final oral presentation.
So the proposal, how many pages? Or is it the
So proposal, I can give you a template for the proposal. So it all depends on the topic, but it has an important components on proposal. Okay. You find much more information on this okay, on Canvas, and also I'll be going through it. Okay, so that constitutes 100%. Okay, and as I said, this is a tri-series. So you are going to do this course and come out with a project proposal. So if you want, you can use the same project proposal to do your final year project work. So that is the capstone project A and B. So that means your proposal you can try to execute in 2 parts, part A and part B, in the next 2 terms. If you do not want, you can also start a fresh project. Okay, so that means you will be wasting your time. So unless until you are not happy with your project proposal this term, but you can use whatever the knowledge gained, whatever the skills acquired to come out with a different project proposal and work under capstone A and B. Is that clear? Okay, and honestly, your GPA is going to be heavily dependent on the project work. So if you want to improve your GPA, the only way is do your project work. Any questions for me?
would you, like, how's it, if you come up with a proposal, would you tell us like which one is good and which one is not good?
That's what exactly we are going to do in the class. So for that, I should know what you are going to do.
So you want us to think about the topic right now because
Yeah, now that's what before you came, I was asking you. The first thing I want to know is, I introduce yourself, what you are doing, or what is your, in future what you want to do. Okay, most of the time, we strongly encourage students to pick up something from the workplace, some topic relevant to the workplace. So it can be a small topic. Please make sure that in research proposal this term, or in capstone A, or in capstone B, you are not going to invent new things. Okay? What you are going to do is you are going to apply the knowledge which you have gained on a problem and demonstrate that you have problem solving skills. So in that process, an important part of engineering is, okay, understanding the current state of knowledge related to any topic. So the topic particularly, you need to choose, pick up the literature relevant to your topic. Okay, so that means, okay, we'll come back. So there is no exam, right? Obviously. So how we are going to assess? So in the exam-based courses, it is rather easier. So why it is easier? Because the question paper will be set, okay, by the almighty faculty, and you need to just answer. But here, you are going to set your own question paper. So that is your research proposal. So you are going to set your own question paper, you are going to write your own answers, and everything okay, certain flavor. Okay, so you cannot copy and paste anything from okay online sources or from any other sources. Everything should be from your perspective. So that means when we read something which you submit, that must be reflected that you have written that. You can use the ideas from various published sources, but when you write, it should be from your point of view. So that means you need to develop communication skills, writing, engineering research papers or technical report skills. So all the time we use a third person narrative. Okay, so that means it is writing as a third person. We'll talk about this a bit later. Okay, so basically through this particular process, RME, then ECPA and ACPB, so you are going to improve your communication skills, both written and oral. Oral because you have oral presentations. So, and also your research skills because you are going to go through a lot of not textbooks, not standard textbooks. You can also include standard textbooks, but also research papers published from various journals. Okay, so all those things you need to study and you need to do yourself. So you have to have a lot of self-discipline for this course, and you particularly the grades for this course will not be related to the grades of other courses, because I know a number of students who got credit or pass, so they got high distinctions for project works. So that is because of your knowledge skills, your workplace experiences. Okay, so it is quite possible. So, and somebody who has consistently high distinctions may just get a pass or a credit for this course. So it is quite possible. Okay, the most important thing for this course is you need to show your research skills, and also you need to show application of your knowledge. So when I say application, hi Jenny, how are you?
非常好，非常好。
How are you?
老师，
Good. So you need to apply. So when I say apply skills, so what type of skills you are thinking in engineering? What type of skills? What is the one most important skill all of us should have? Okay. Any other things?
problem solving.
Problem solving, analysis. Any other things? Communication. Okay. Any other things? What is the one most important thing without which we can't really work? Say again? Somebody said something? Knowledge, of course. Inventions, not really. thinking in abstract terms. Because creativity can be anything, you know. We all create, we were all created. So we can also create. So that's, and the tools I'm talking about, engineering tools. So you're talking about the techniques, analysis. So what is the single most important tool? No.
Observation. Observation.
Observation, okay, not, okay. No, that's not what I want to drive at you.
Tools.
I think some of you have not done this particular, you have not used this particular tool well in the last term.
Simulating.
You are very close. So this is, we are going into now, you know, the two-letter word. What is that two-letter word?
ChatGPT.
So we are not going into that level, but before, so a primitive level. Very close. So it is, there are a lot of simulation software available.
Simulating.
So the simulations available for engineering purposes. Simulations can be your thermofluid simulations, or your simulations can be AutoCAD, a bit more advanced SolidWorks, or finite element theories. So any engineering problem, so if you want to do, prove, so you need to have a prototype and study. Otherwise, you need to create a model, simulate the model using the software tools available. So simulation and using engineering software packages is a very important thing. For example, working model. What is working model? So it is a simple 2D software to simulate different things. And unfortunately, I think most of you, or some of you, could not do this for your assignment. Why? Because this was a tool. Right? So you're supposed to apply this tool for that course. And for this course, R&D course, okay, if you want later for project A and project B to score a high distinction, then let me tell you, you must have some simulation works in your report. The simulations will depend on your topic. Okay? So if you are doing a thermofluid related topic, so some thermofluid related software, some fluid software, or some fluid mechanics software. So if you are doing analytical tool or product development tool topic, something related with SolidWorks and simulations, and where you are going to say that, okay, your actual analytical calculations, and you are going to demonstrate using the tools that your product can work. So an important application should be there, that is the tool is simulation techniques. So using the any software packages, advanced packages related to your topic. So if you are doing a renewable energy related topic, so you must use the systems advisory model or any other advanced tool. So to demonstrate that your renewable energy model can be simulated using this particular software, and your analytical results will match or will collaborate with your jelly. How are you? Good? Online. So, am I scaring you? Now, do you think it is better to have an exam-based topic? No, but this is because you are going to do this for nearly 1 year, right? So you are going to really benefited by this. And if you can choose a problem from your workplace, so it is like hitting two birds at one shot. So you can improve your knowledge at workplace, at the same time, you can score a very high grade for academics. Okay, so the best thing I was asking at the beginning of this course, so I need to know you better. So there's not much to teach in this, rather than mostly to guide you about your problem and what to do. Okay, whether your problem is acceptable academically, okay, or if there are any limitations you need to put for your problem. So you need to think right now, and you need to. I'll be discussing with everyone. So you need to tell what you're planning to do. So whether you want to do something from your workplace, or if you're working with the police, then what type of engineering problem you can take. So because some of you may not be in engineering related field. So in such case, you can pick up something related with engineering management. So something related with operations management. Okay, so something related with quality management, wherein there is a scope for you to apply some elements of engineering tools and techniques. So everybody can have something related to engineering and engineering applications. Okay, so the first thing is what research is. So we need to understand, because the title of the course is Research Methods for Engineers. And all of you are going to be professional engineers, and you are going to get a Bachelor's of Engineering degree. And this degree is focused more towards training you as design engineers rather than the practicing engineers or backstage engineers. No, you just go to a mechanic, he solves your problem, but he can't apply the theory, what exactly is happening. So whereas you will be a trained design engineer. So what research is, so we need to see here that it is a systematic process of collecting, analyzing, interpreting data to increase understanding of a phenomenon about which we are interested or concerned. So this phenomena is the problem. So you need to identify a problem. So then you try to solve the problem systematically, applying all the engineering tools and techniques. So that is research. So research is not just collecting information. So not gathering information. You can see research is not about gathering information. Okay, so it is simply not gathering information. Okay, and also it is not finding information which is very difficult to locate. Okay, so just spend a few hours to locate some information about some engineering principle and write about that. So that is not research. Okay, so research is not simply collecting information, or not simply collecting information which is very difficult to locate. Okay, and also research is not about telling something from one location to another location. So transporting facts from one location to another location. So that means you read some old engineering journal and write about that and what they have done in some other journal. So that is not research. So that can be a part of review rather than research. Okay, so always the research originates with a problem or a question. So please note there must be a question or a problem. So based on that problem or question, then you try to apply whatever the knowledge which you gained over the period of last 1.5 year, 2 years, then try to apply the knowledge. Okay? So ultimately, it is not the end result that is important. So let us say you want to create a small product. So how successfully you generate this product and how successfully you prove its application. So that will not give you a high distinction or a high grade for this course. So what is required for this course is you need to demonstrate that you have done, your objectives are very clear, okay, and you have done a good literature review, and you have applied engineering tools and techniques to solve this, okay, and you have used a relevant, okay, software, and you've done some calculations related to the topic. Okay, all those things are much more important than your end result. So end result, whether your product is a success or failure, you can still get high grades and you can still get recognized for your work done. Okay, so provided you complete all those things. So clear objectives, okay, then a very good literature review, then clear methodology applied, then all the engineering tools and techniques are applied in the solution of the problem. So always there must be a goal, so you need to have some clear objectives. So objectives means normally people say that you want to reduce the global emission of carbon dioxide. That cannot be your objectives. So your objectives must be quantifiable. Okay. So for example, you are working in a manufacturing setup, and there are defects, coming in your manufacturing process. So you can have an objective to reduce the percentage of defects in the process. So that can be an object which is quantifiable. Okay, so your objectives must be quantifiable. So your final goal, okay, you need to achieve something, but that something cannot be vague. Okay, so that something needs to be quantifiable. So we, as engineers, we always speak engineering knowledge, which is, okay, quantified. We talk in terms of numbers. Alright, so it requires a plan. Okay, so the plan, are you doing the management of design course? Not yet. Okay, so you study some of these things in the course. Okay, so how to plan things. Okay, so again, there are tools where you can use the tools in planning. So say a simple tool is your Microsoft project. So where you can have what are the various activities related to your topic. Identify different activities. Then you can have timelines. So you can prepare a chart known as the Gantt chart. So that is your action plan. So in this course, you need to come out with 2 action plans. So one is for your project A, another one is for your project B. So in the proposal must contain action plan. Okay. So anyhow, the project proposal is at a later stage, so we can talk about that a bit later. So any problem usually divided into sub-problems, right? So your problem can be a broad problem, but when you want to solve that problem, so what we do, we try to break down the problem into manageable sub-problems. So divide the problem into sub-problems. And this is part of your project planning. Okay, you can break down and identify the timelines, so that becomes your project plan. So always okay, you need to make some assumptions whenever you want to solve a problem. So without assumptions, it is not possible to apply the necessary theory in analyzing the problem. For example, you want to solve a simple fluid mechanics problem, let us say. So we need to assume that the fluid is the nature of the fluid, a laminar flow fluid. You need to assume that it is a systematic flow. So some assumptions are required in solving the problem. Okay, so you need to state those assumptions, and also any problem requires collection of data. Okay, and of course analysis and interpretation of the data. So what is meant by data?
Historic records.
Yes.
Historic records.
That?
Historic records.
Oh, historic records. Not really. So what is data?
Running perimeters.
Parameter. Okay, so broadly we can categorize data into primary data, secondary data, tertiary data. Okay, so the primary data is where you're going to record for yourself. So you want to stand outside and you see how many between 5 p.m. and 6 p.m. Okay, how many number of vehicles pass through this particular junction every 5 minutes. So what you do? Just go there and record yourself. So primary data means you are doing your experimentation, you are going to collect the data, the numbers, okay? So secondary data is somebody did already the data. For example, you want to study the solar radiation data. So we want to design a renewable energy system, so we need solar radiation data. So there is no need for you to record the temperatures daily or find out the solar altitude and azimuth for yourself. So because any meteorological observatory provides you such data. Okay? So you can record, you can take all those data, you can acknowledge and you can state. So this is the secondary data. Okay, so data you can actually design for yourself, so you can do independent survey, you can do your own experimentation, collect data, or you can also collect data from published sources. Okay, so if you are working and your problem is related to your workplace, so you can also get primary data. So primary data is always considered as more valuable than the secondary data. Because for primary data, you are the father and you are generating it. So the credit goes to you. So secondary data is provided to you, but you are allowed to do further analysis. So you can apply the data to your problem. As I said, the solar radiation data. So it is unique. So you can just collect from the meteorology departments online. So you can use. So which you have done this as part of your one of the assignments, right? Okay, so always the problem starts with the hypothesis. Okay. Okay, all these things are a bit theoretical. So problems can be, depending on, as I said, your workplace, or depending on based on your observations, or based on your interests. So you can always choose a problem. So this can be a logical supposition. Sometimes this particular thing comes, particularly in pharmaceutical industry. Let us say you're going to test two things. So there is drug A. So there is a medicine A, let us, which is currently used, and you come out with medicine B. And now you make assumption that your medicine B is better than medicine A. So this is a supposition. So you have to test collecting data and then validate whether medicine A is better than medicine B or not. Okay? So such things are also part of research. So this is called hypothesis testing. Okay? So there are different types of research. Okay. So there could be assumptions, as I said, okay, related to a problem. I just skip some of these theoretical things.
So will you share this file with us?
Yeah, there is no problem sharing this, but it may not be much useful. I have no problem.
Any sample reports?
Say again?
Any sample reports?
Oh yeah, we'll go slowly one by step by step. Step by step. All right. So the research tools we frequently talk. So when we talk about the research tools, we talk about the research tools which in mechanical engineering. Okay? So the research tools, as I said, one of the important tool is the computer simulation. Okay? In addition to your analytical tools, the statistical tools, okay, and your analysis tools. Okay, you need to use those tools. And the most important tool you need to use is the simulation and also analytical tools. So the simulation can be finite element analysis, or it can be product related simulations, it can be stress analysis, it can be thermofluid analysis. So there are different types of things. Then the methodology. So what type of methodology? So methodology depends on the problem chosen by you. Okay? So what type of problem? So what type of methodology? So if you are considering a product development related topic, so let us say you want to design a small product. Okay? So you need to know the requirements for the product. Okay? Any product development topic should start with requirement analysis. So you need to know what are the requirements for that product. How do you know the requirements for a product? Specification, product specification. Now suppose iPhone. So what requirements? How do you get the requirements for a new iPhone? You're right. So you want to reduce the cost. So the cost of, so the customer wants that the cost should be reduced. So that is a requirement. In addition, can you share some requirements or requirements for a future iPhone?
Quality.
Quality is again a vague term, so you need to define.
Storage.
So you want something 10 terabyte storage. So unlimited storage. Anyhow, it is there, iCloud. So that problem is no longer a requirement. So if you want, you pay. So you can have direct iCloud. Right? So what are the other things you want?
Flexible.
Okay, so your requirements will be specific.
Material.
So the cost comes into material. So what type of material you want? You want lightweight. So probably not 150 grams, you want only 10 grams less.
But you need to see whether durable also.
No, we are talking about requirement. The next stage is, these are called customer requirements. What the customer wants. Customer wants everything on the earth. So that is not a technically feasible, right? So what else you want from the future iPhone?
Camera.
Huh?
Camera. Better camera.
Better camera. So you need to define. So now they say how many megapixels. So talk about in megapixels. So again, that is a vague word. Design means what? No, probably if you ask me, I'll say, okay, I want iPhone which should never be charged. So it is just like based on the hand movements, it should charge itself. That could be a reality in future. Okay, no need to charge your phones. Okay, so there are many requirements. So any product development or product design, so must start with requirements. So how do you get these requirements? Based on my your problem statement. No. Okay, so in engineering, one of the most important thing is collection of data, right? So collection of data should start with an experimentation. So that is when you have lab or practical things, you're working with a machine. Otherwise, something like customer requirement should be collected. How? By designing a questionnaire. So we need to design a questionnaire, so then collect what the customer wants, so through a survey. So customer survey is part and parcel of product design. Okay, so this type of data collection is primary, but you need to design this questionnaire for that. Alright? So when we talk about the methodology, so whether you're following a design methodology or you're following a analytical method or statistical analysis or you're following a fluid sciences or just what we call analytical methods, so you need to identify what type of methodology you're going to use. Okay, so the tools of research is the first one is the library and resources. So the library is, as I said, online. Now you're lucky. So 30 years back, normally as a research fellow, we used to go and sleep in the libraries. So even now, if you go to NUS or NTU, you can see all the time. So the libraries are filled with students. So that is just to old journals and a lot of books you can read. But now that is reduced because of online resources. Okay, so you need to go through RMIT library. So you have thousands and thousands of articles and journals. So you can easily sort out. You can have the query-based sorting. Okay, and you can find based on your keywords. Okay, you can find something relevant to you. So which was work done by other researchers and it is published. So those things, and also it allows you to save in PDF, and you can print yourself. RMIT pays thousands of dollars to many publishers all over the world, and you can, as long as you're a student, you can access. Okay, so the moment you graduate, then you don't have that access. Okay, and you need to use the library resources effectively for this course. So not only for this course and also for ECPA and ACP. Okay, after that the computer technology mostly refers to using the Microsoft Office and also other relevant simulation software tools. As I said, without any amount of simulation, whether it is a stress analysis related or whether it is SolidWorks related or thermofluids related, so it is not possible to get a high grade, because it becomes an integral part of an academic achievement. Okay, measurement is where you are going to collect data or you are going to create data or generate data. Okay, and applying the statistical tools. So basically, data analysis tools. So there are different types of statistical packages. Okay, so if you are generating a large amount of data, so some students they collect, they'll be analyzing processes at the workplace. So in that, they'll be collecting lots of data. So if it's all numbers, so how do you make some meaningful interpretation of these numbers? So there are some statistical tools available. So you can plot the data, you can measure the capability of the processes, you can come out with control charts. Okay, there are a lot of things which you can do by applying the statistical tools. So students where the problems relate to lots of data, so you must know how to use a good statistical package. So nowadays, for example, simple things like correlation analysis. So we don't do So you can simply use a statistical package and you can do lots of calculations. If you recall, you've done this for your renewable energy, so wind data, analysis. So how you made the meaningful interpretation of 1 year wind data collected. Okay, so such things. So Excel is a simple, okay, office tool, but there are more advanced statistical packages. So like Minitab or MATLAB. So you can use based on the problem. Okay, so language basically refers to scientific language or technical language. So scientific language or technical language implies it is always the third person narrative, and we don't write poetic languages. So we do not make it so beautiful or poetical language, rather than simple, straightforward language. Okay? So no two meanings, single meaning. And of course, ultimately, the human mind. So that's where we apply our logic or analysis. Okay, we talked about all these things. So statistical tools. Okay, another form of communication is the written communication. So when you write these things, so over time you can develop this skill. Okay, so actually all the time we need to write what it means. So no complicated sentences. So we don't write too many negatives in the sentences. All right, so I'll skip this. So human mind, we don't. Okay, so. Okay, I skip this, all these things. Okay, this collaboration with other minds. So this is where normally when you're doing this course, you're going to have your own problem. So no two students joining. Okay, so no students can have the same problem. Exceptional cases, both are working in the same company, both are assigned to the same project. Okay, and in such cases it is possible to have it. But nonetheless, so when you are doing this, so you can always discuss with your colleagues. So you can discuss with your managers. So you can get help from all sources. Okay. So the advantage here is, so you can get help from your office colleagues, your seniors, or your classmates here, including your teachers, not only from me, from others also. So some amount of collaboration in doing your research project is acceptable. And you can also use your girlfriend or boyfriend, they help. You write something and ask them to read through. They find out more mistakes. So you can refine your language. So there are various ways you can take help from other sources. Okay, I skip all this. Okay, so next I go back to this course. Okay, the main person, RMIT coordinator will be Dr. Hamid Kaya. So Dr. Hamid also delivers another course that is the management of design, research and management of design. Okay, this is myself. These slides are used for on-campus students and it's not directly relevant to you, I'll go through the slides where it is directly relevant to you. Okay, so basically Australian degrees, so they have Bachelor of Engineering, means it is a 4 years engineering program. Okay, and in the year 4 you must do a project work, independent project work. After that, if your GPA is quite high, okay, you can straight away go for your PhD. So there is no need for you to do a master's course. Okay, so after Bachelor of Engineering, straight away you go. No, some of your seniors, they have done and they have completed their PhDs. And one of the students who was like you 10 years back is Dr. Williams. So she was a student with perfect GPA and she straight away went to RMIT, did her PhD. And she got her lecturership and now she's coming here as your project supervisor and also for some courses. Okay, so that's why this course is a bit heavy in the 4th year. And also it helps you for your GPA. Okay, now this is important for you. So this slide is what I was emphasizing. So this course you are going to do the research methods for engineers. Okay, under this course, okay, I discussed at the beginning. So you have the 4 accessible components. So one is research problem, then research literature review, then you have the research proposal, then you have oral presentation. So that means the main outcome under this course is coming out with a research proposal. So research proposal is a document where you are going to tell, so these are the objectives of your problem. Okay, so this is the method which you are going to apply, and this is the current state of knowledge. So that is literature review, and you are going to tell, so this is my action plan. Okay, after that, when you join the engineering capstone project A, so here now the entire project proposal you are going to solve in 2 terms. And the project A, some of the work you complete your project work and again continue in project B and try to summarize, try to complete all your work. Okay, so your research proposal you are coming out under this course. After that, you are going to solve this over 2 terms. So that will be your capstone project A and project B. And the capstone project A, so it is something like your 50% of your project work you are going to complete. And the remaining 50% you are going to complete under project B. So you can see that, so whatever you are doing, this is 12 credit points and 12 credit points and 12 credit points. So you have 36 credit points. So this is quite heavy. This is mainly because if your GPA is very good after that, so it allows you straight away go for a PhD. So you need to plan this for a long term. Okay, it's not difficult, and as I said, most of our students are doing one course which is very well, means that is the project work. So that is mainly because you guys are working for several years, and you have the advantage of a workplace where you got the facilities. So therefore you are definitely should be able to do better than on-campus students, many on-campus students. Okay, so is that clear first? So first, under this course, EET 2562 RME, so you are going to come out with a research proposal. And I think some of you are going to enroll next term project A, right? And some may not be, some may be the following term. So whatever it is, if you want to continue with the same project proposal which you do this term, it is fine. But if you want to change, also it is okay. But generally 90% of the students will continue with the same topic. All right. Okay, so this is the assessment part I was talking about beginning. So you have 20% weightage for the research problem. Okay, under this you are going to just write what are the objectives of your problem, okay, and what is the background analysis of your problem. So it can be 4-5 pages, it can be 6-7 pages. It all depends on how effectively and how completely you can write. Okay, so generally in engineering, you just don't write. So wherever possible, you are going to put some sketches, show some graphs, show some diagrams, so something relevant. So the figure always speaks 1,000 words, right? So you can use appropriate figures, sketches, diagrams, not only in your proposal, throughout your project work. Then the next one is the literature review. So you can see you have 30% weightage for this. Okay. All the date lines have already put on canvas, so you can just follow those date lines. Then this is your proposal, so it has 40% weightage. So after that you will have this oral presentation 10%. And let me tell you, every component is important. So to score high, you need to have every component is important. So you need to put your heart and soul and mind in all these things. So, as I said, the only difference between this course and the previous course is, so here you are going to set your own question paper. Your question paper is something your project proposal. So this, what you are going to write your project proposal will be helpful for the project A and project B. Any questions on this?
Frontier is what? What's frontier?
Second?
Frontier. How like the underline.
Oh, this, frontier is something like boundary. So because I was telling you sometimes, we use some vague words. So instead of vague words, so you need to clearly define the boundaries of your research. Okay, so you simply cannot say that your objective is a process improvement. Okay, so you need to tell what process you are talking about. So what is the current process capability? So how you are going to improve the process capability from what percentage to what percentage? Okay, so you need to have more clarity and define your goals. That is your frontiers. Okay, so the main thing is that clarity of your thinking. Okay, and normally we tell informally that a good project work means, okay, so should have at least clear objectives. Your objectives must be clear. So if you can define your objectives clear, so consider 50% of the problem is solved. So most of the confusion comes, coming out with a clear problem. Okay. So this is where actually I can be of help, but I should know better. So that means I should know what type of problem you are doing. In the past, actually, we used to have 6 sessions for this. So normally, the students used to come out with 4 or 5 PowerPoint slides. So they used to talk about their problem for 5-10 minutes. Okay, you can still do this for the next session. But since now the sessions are reduced from 6 to 3, okay, so the best thing is that you just email to me, so I'll be able to communicate back to you whether you are chosen problem is okay or not okay. If not okay, why it is not okay. Then how you can rephrase it, or how you can change it in a better way. So every element of your submission, be clear. So every part of your submission, before you upload for assessment, okay, before you upload for your assessment, you can always email to me. You guys have my email, right? Yahoo.com or Arabic email, and just get a feedback. After feedback, then you can, if you want, you can improve and you can submit. But if you submit without any feedback, then it is more likely that you may get a lower grade. Okay, so I can be helpful because I'll be doing two things. So I'll give you a primary feedback, provided if you communicate to me. So whatever, let us say your research problem, so you're going to, before you're going to submit, you just email to me, then I'll be able to reply to you. Online? Okay, so this course has also oral presentation, right? So oral presentation is mainly used because your project A and project B also have oral presentations. And project A and project B oral presentation will be a bit heavier. So for example, you have project A 25% and project B 20% weightage. So substantial. Oral presentation is mainly to test your communication skills, oral communication skills. So not only the written communication skills, but also how you present your problem, okay? How you present yourself online. So for RME, the presentations will be online, okay, through Canvas. But for Capstone A and Capstone B, it will be conducted in the classroom. Okay, so for RME, the maximum time is 10 minutes. So you need to come up with your PowerPoint slides based on your final research proposal. Yeah. So we go a bit more towards your problems. Okay, so basically we always deal with different types of day-to-day problems, right? Okay, so the problems can be, improving a process, okay, reducing the defects of a process, or improving the capability of a process, or designing new products, okay, or improving the manufacturing or the production processes, okay, so improving the quality of a product, so reducing the cost of the design or the production. So there could be day-to-day problems related to your workplace, your engineering. So you can pick up any such problem. So engineering is always a profession, right? It's just not an occupation. So you need to apply the engineering analytical tools and techniques, so to solve a problem and also to find a solution. So these problems requires advanced analytical tools and modern computational power. So here the computational power refers to the simulation techniques available. Okay, so a bit advanced to this will be your artificial intelligence. So we are not going head to AI related problems. Okay, so in a flowchart we can see basically the engineering problems, okay, there's no shortcut directly to solve your problem. So you can't solve a problem directly, no shortcuts. So you have to do a mathematical interpretation. You need to come out with a mathematical model, okay? So then you do the analysis of this problem, okay? Then get some analytical results, okay? Then interpret your results. So if everything is okay, then you are going to find a solution, okay? So in this process, not only the mathematical modeling, but also your simulation techniques will be useful, because many problems can be solved using simultaneously mathematical tools and also simulation tools. So if you see the general engineering design procedures, particularly if you are going to deal with a product development, okay, so you need to have the product specifications. So the product specifications comes from customer requirements. So how you get customer requirements? So you need to come out with a questionnaire, you need to do a product related survey. So from customer you get all the requirements, then what you do with the requirements? Yeah, the customer, for example, phone, he wants unlimited storage, we can find a solution. Okay, no battery, then lightweight, and the cost $10. So the customer wants many things, but we need to look for technical feasibility. So we need to find out the technical feasibility. So that means we need to transfer the customer requirements into technical requirements. So there are different methods to transfer the technical customer requirements into technical requirements. So we can say, okay, the maximum weight can be reduced only to 100 grams, not less than that. So that is a technical requirement. So it's a technical constraint. So we can transfer all those customer requirements into product related requirements, and you can do a design synthesis. So, okay, after that, then you can come out with what are the various design conditions then, and also the design drawings. So you can come out with product specification, okay, in terms of AutoCAD and in terms of SolidWorks, you can prepare an engineering drawing for the same things, products. So then you do the design analysis. So if the criteria is met, then you come out with an optimization of the design, then you can do some optimal solution, then you can prepare a prototype and you can do testing. If not, you can just revise this, okay? So you can improve, adjust your geometry, specifications, and still all your criteria is met, okay? Then come out with your prototype and test. So this is a very standard method of product design. So not only we are anywhere for any product, they follow the similar flowchart, analytical way. So when you are doing the 4 stages in the engineering analysis is that first identification of your physical problem. So in the first part of your assignment is coming out with the research question, research problem, the basic objectives. So then you are going to come out with an engineering model. Okay? So then you apply the mathematical model and analysis. So this part, so you are going to use not only the mathematical skills, analytical skills, simulation skills. Okay, then you are going to try to interpret the results. Okay, so this is a basic flow down of engineering analysis. How do you select a topic? Okay, so it is all your passion, your interest, and whatever the facilities you have with you. Okay. So the university will not provide you any facilities because you're a campus student, but You can always, if you want, you can go back to the on-campus and continue your studies. So there you can get facilities. But because you have chosen not to be there, right? So you need to use, we strongly recommend pick up a topic from your workplace. So if it is not possible, then pick up something related to your interest, your passion. So which topic is more interesting to you? So whether it may be a renewable energy system, designing a renewable energy system, or it can be a product design related topic, or it can be simply a process improvement, or it can be simply an engineering management related topic, or it can be a quality management related topic. So you can choose depending on your passion and interest. If you don't have a problem from your workplace. Otherwise, first priority is always workplace related problem. Okay?
So, like, quality management and learning management, how do you apply simulation?
Oh, there are many simulation software available for product management. So simply network flow diagrams you can apply. Depending again on what type of data you're collecting. So you name a topic, you have simulation tools. So even operations management or engineering management or quality management, there are related software packages available. So that shouldn't be a problem. Okay, so you need to be specific about your topic. So that means when you come out the objectives of your topic, so you need to be clearly state your objectives. So don't state that you want to reduce the greenhouse effect of the earth. Okay, there are some objectives which are vague, okay, you cannot quantify, so try to avoid all those type of objectives. And normally we are doing academic related project works. Okay, you are not going to, you are not a research or a design engineer yet. Okay, so you are going to be tested and assessed based on how effectively you use your academic skills. So that is where your report writing, your model presentation, your analytical skills, your application of the engineering tools and techniques, all those things matters, rather than whether you have successfully achieved all your objectives or not. Okay? So let us say you want to reduce the product defect rates at your workplace from the current 10% to 2%. So let us say at the end of your whatever the modifications you have done to the process, your defect rates has increased. So you have not achieved your objective. But still you can get high distinction. Why? How? Whether you have applied all the methods, whether you have done a good literature review related to the problem, whether you have done a good engineering analysis of the problem. So the end result is not important. This point is very important. So it is not the success or failure of your objectives, but how you entirely done your work, how effectively you have applied the engineering tools and techniques. Okay. And let us say you have achieved your objectives, you say that, yeah, I reduced my defect rates, so I've done my report, everything. But your report has a lot of lapses, let us say. Then you may simply get a pass, though you prove that you achieved your objectives. So what is more important is that the demonstration of effective report writing, effective application of your tools and techniques. Okay. Summary, effective demonstration of your knowledge skills. Is that clear? Yeah. So this is Now, before I go through the topics, so now I think class size is about 30, right? 29 students, I think. So I'll start with one by one. So what is that you're planning to do? We don't have much time.
After the break.
So next time I meet will be only after 1 month.
Think
So today is 25th January, I think 15th February. I think next session is 15th February, right? When is the next session? Huh? 15th February. Then we have only one more session, 15th March.
That's it.
Huh? This is simply, there is no exam. There is no pre-exam workshops for this. So it's when there is no exam, no online, yes, Canvas. So you do find anything. No, forget about the one thing is you need to elevate yourself. You are going to be more proactive. So you are going to be taking more initiatives, and yeah. So most of the time you can depend on me. So the communication is through email. So WhatsApp, no. No, it is one-to-one because your topics are different. Your topics are different. I'll start with Darren. So, Darren, tell me. No, we have a lot of time to discuss with each and everyone. So, what exactly, where are you working and what is your interest? What is your
Where I work in a automation company. In charge of mechanical department. Got 2 engineers, lead them,
Under you?
technicians. Yeah.
2 engineers, so you are going to
I'm going to use
start with the
that.
fantastic topic. Okay.
Yeah, so
Any problems currently you are?
actually a few because it's
Guys, I think you can also get good ideas by listening. Okay, go ahead.
Yeah, okay. There's a few problems that face with our department. I mean, these are all problems that I face. Some projects they work on, we've got faulty sensors that when the projects that we do, to find out how to get better sensors. So,
Okay, these type of problems, simple mechanical replacement or those type of problems cannot be real engineering problems for project work. Okay, so for example, this is not working, so I replace. So this camera is not working, I replace with it. The specifications are not sufficient, so I put a camera with more specifications. So those things are considered as backyard engineering related issues. Okay, so where there is not much scope for you to apply engineering analysis, so you cannot come out with engineering drawings, you cannot use your AutoCAD skills, you cannot use your analytical tools, or no simulation is possible. So you need to pick up some topic where there is scope for you to do some amount of research. So where you can see, okay, where is the competitor? So what type of processes the competitors are using?
so coming to my second problem. We work on conveyor systems, so we use a lot of stainless steel conveyor frames. Which we usually import from Malaysia. It takes a long lead time. So we're looking at probably how we can manufacture it locally. So one of the things that we do is using this material, using 3D printing.
So this type of problem is precisely what we look for this course. because there's a scope for you to do a good amount of research on materials. Okay, so what type of materials are suitable for conveyor belts and what type of adhesives, material properties you can study, and you can also study depending on your requirements what type of designs. So you can come out with conceptual designs, and once you have conceptual designs, so you can finalize. Always when you want to design something, so don't design only one thing. So you always have three designs, A, B, C. So you need to have three mini alternative designs. Okay, then you all apply the weighted index method, which design better suits to your requirements. Then choose that particular design, and for that particular design, come out with engineering drawings. Okay, then if possible, do a prototype and do testing, do validation. So that can be an excellent problem. So Darren's problem is solved. No, there is, when I say solved in the sense, no, because when I speak, it applies to everyone. Huh? So solved in the sense, there is a good scope for doing literature review. Okay, there's a good scope to do some engineering analysis, and there's a good scope to do some simulation and some experimentation. So all these things should be there for an academic project work. Ultimately, let us say he is not able to develop anything. It's okay if he can do his project work. That's a fantastic problem. Yes, Shishwendran.
Working in the aviation restaurant,
Mhm.
quality inspector.
Quality inspector.
So mostly we do inspection on paints. Paints.
What type of inspection?
So we actually check for cracks, defects, parts. So usually we determine which
Non-destructive?
yes.
Non-destructive, okay.
And yeah, then we use penetrant.
Liquid
First.
Okay, so you can pick up any particular system where you're going to use non-destructive testing methods. Okay. So there's a lot of literature available on non-destructive testing methods for aviation industry. So identify what type of cracks, what type of lines. So a specific problem. Yeah, so normally some students, they do this type of problems. So you can pick up something related to non-destructive testing, and whether you're going to improve a particular methodology or whether you're going to come out with a small fixture. So for example, you want to use your equipment on a particular surface, let us say, you don't have, because this equipment doesn't fit, so you need to have a fixture or a jig. So you can come out with the development of a jig so that you can effectively utilize whatever the equipment you have. So here the problem is a bit of non-destructive testing, but more towards the development of a jig or fixture to facilitate better utilization of the equipment.
We have a problem parts. It's been damaged by the machine.
Mm-hmm.
So definitely
Perfect. You can do. Yes, DJ?
I work in a chemical plant. I'm a mechanical engineer. So my job is
Chemical or pharmaceutical?
it's a chemical.
Industrial chemicals.
Yeah, it's like organic solution, kind like phenol,
Or phenol.
PTA.
Okay.
Yeah.
Adhesives.
Yeah, so I'm the mechanical engineer. So what I do is usually manage contractors lah, then arrange to fix shutdowns,
Logistics.
turnaround. Not really logistics lah. Also
Equipment control.
equipment control, reliability, turnaround management.
Okay, lead time. Okay.
Yeah, plan for equipment repairs.
Okay. So it's more on operations management. So you can pick up something related to improve the overall capability ratios of a particular process related to your workplace. You can do that. So more towards operations management.
I mean, also identify problems also, like maybe
Okay.
there's pumps with high vibrations.
It involves some testing.
Testing, we do vibration checks and also
No,
overhauling
because
of pumps.
You might be doing a lot of things related to logistics and maintenance and planning, things like that. So you need to focus to one particular point where you can apply whatever the experimentation or the work you are doing to improvise the process. You can think about it, so it's not a thing. So how about Eva?
Does validation counts?
You are
Because molding industry,
molding.
molding, yeah. So I mainly do validation, IOPQ,
Validation.
yeah.
Validation of?
Machines,
Oh, testing and validation.
yeah. That's the machine, yeah.
Then you can come up with some problem related to that.
Yeah, there is some problems, yeah.
So shouldn't be a problem.
I hope so.
So no problem for you then.
I'm not sure.
Coming out with a no, because guys, one important thing in life is that not only for this course, the time flies, and we have clear deadlines, right? So we need to plan ourselves. Alright. So next, sorry I don't remember all names. Yeah.
Yeah, I would.
这样 don't know what to do.
Yeah,
Yeah.
yeah.
哦，
Mhm.
我的是 more of maintenance.
Testing side.
Testing side.
Yeah. Problems wise, it's there to find problems.
No, please, you need to make sure that when you are choosing a problem, so consider that you are not only doing for this course, but you are going to continue this for the next 2 terms. That means, there must be good scope for you to do literature review. So that means you need to go through articles published by various other people who work on supply chains. If you have something related from your workplace, that is very good. Yes, Azhar? Heavy machines, cranes. Say again. What is exactly your role? So you do troubleshooting, so can you find any problems?
My company documentation very bad, like very hard to get trending on this. Walao.
So you can think of formulating a problem related to that.
Makeup.
Logically get one.
So in the next, by next Monday, I think all of you can submit your problems. You can write, you can send 2 or 3, 4 PowerPoint slides, okay, about your problem, and just email to me. So normally I'll reply in a day or 2.
Like for example, this component, if you want to replace it, what kind of
So you can keep thinking, so but don't think too long.
Just to talk about the problem statement, the problems or
how I got a craft out
No, I'll tell you after some time of the break. I'll show you normally what type of problems done by the previous students and what type of problems you can do. A bit more we'll go into the levels.
preparations for
Okay,
projects.
so before that, I want more worried about people who are not picking up something from our place. So as long as you are able to pick up something from your workplace, it's good. Okay, so not only me, but also you can get help from your supervisors, your managers, okay, your colleagues, you know. Please, there are thousands of people in the world, you know, who are willing to help. So not only that, you know, you get benefit, but they also get benefit by it. Yes? Okay.
So that's for your third.
If we assist our corporation engineer to check all type of crane, like tower crane, borer crane, or crane, and also razor leaves, and motor.
Okay, so you're dealing with cranes and other so what type of work you do?
Inspection, check the functioning.
So you can study, for example, swaying of cranes or any problems associated with it, any specific problem, any particular model. Okay, you can further investigate into that. So there is a possibility you can come out with a good project proposal from your own place. So you need to think about this. So because some students they also did about swaying of cranes, you know, and also optimizing the performance of the crane, reducing the failure of cranes. So particularly if a particular model of a crane gets faulty, then identifying the problems and coming out with no replacement, you come out with another fixture or jig so that you can improve the performance of this. And not only for a crane but also it can be for any other machine. All right, so next we move to this side. Adidas.
Okay,
What's your name?
Vinod Kishan.
Huh?
Vinod Kishan.
Kishan.
Yeah.
Okay, Kishan.
So I'm working in the Air Force under engineering, ground-based systems. Yeah, so I do
Changi?
maintenance. Yeah, Changi. So I do maintenance on the ground-based systems.
What type of systems?
We have a door, like those hydraulic doors,
Doors.
generators. Yeah. Mostly, civil engineering lah.
Oh, not this heavy vehicles.
No, heavy vehicles done by commercialized really.
I see.
Yeah. So, yeah.
So Kishan, so what is the problems you face at your workplace?
I mean, every system got their own problems.
Identify one particular
Yeah.
system, I understand that. So try to do some literature review, identify the problems, then come out with a proposal.
I will think of the best one first.
Yeah, because you do not have much time, right?
Yeah.
So next,
Similar, I'm also a maintenance engineer.
same.
No, I work
Used
at-
to be said.
Yeah, used to be safe. So what I'll probably do is that based on my system, I'll do a trending to see what kind of what components or what systems have the highest defect rate, and we will try to quantify the defect rates to see if I can improve the defect rates.
It sounds very technical, but no, anything where you can define in terms of quantifiable things, your objectives are good. So you can always find relevant literature. You can always find the right methodology and some simulation techniques to do that. Okay, so then come up with the problem and. So by Monday, I should receive from all of you 4 or 5 pages, PowerPoint slides, just different. I'll tell you what I expect you or what you should do. Next, Charlie.
So my job scope is similar to Dora. So it's a molding my company is a molding company, and I'm a process engineer. So kind of to ensure that the process runs smoothly lah.
So no bottlenecks in the process.
So any
You have an
complaints
idea
and-
about what is meant by control charts? Is it-
flow
You know?
flow charts.
Control charts. So for example, a process is working. So what is the upper limit of a process? What is the lower limit of a process? So the process always acts in a range, right? So based on that, you can also come out with process capability. What is the capability of the process? Then how you can improve the capability of a process. So these are very good technical problems, but it requires you a lot of data. If you can get no, don't underestimate yourself, because all of you have, some of you have several years of work experience. So the only thing required for this course is that you need to just show your skills. Forget about the mechanics of machines course. Now this is totally a different one. I think that sounds okay. Yes.
My current job is drafter under electrical engineer company.
Electrical engineering.
Yeah.
Okay.
So not related to mechanical engineer.
No, it's okay. Electrical is not a problem. So you can always relate to mechanical.
But I
So
still
what job you do?
I help engineer to update like all the cable routines or like lighting protection. Yeah. Or yeah.
So you can find some problem where you can apply your knowledge from the courses.
Yeah. But I quite new. I just joined the company.
Oh, you just joined the
Yeah.
company.
So I.
Oh, you will be given some training, right?
Yes.
Okay. Always because she pointed out this thing. If you join a new company, or if you're going to leave a company, let us say after 3 months or 6 months, so what will you do? Die.
Take out all the company secrets.
No,
Delete all your books.
this is where normally we do in our day-to-day life also, this is what is called, it's a very important thing in engineering. So it's a 4-letter word. What is that? Die is only 3 letters, right? No, it is simply a risk management. Risk. For any process, for anything, there is a risk. Even in your product, so there is a risk. Right? So we need to identify in advance what are the risks associated with your project. So risk in undertaking the project work, a risk in doing the project work. Okay, so you need to identify and you need to have alternate plans. So if you are retrenched, what will happen to your project? You can't say that, no, I got retrenched, so hands up. No. Hands up means okay, re-enroll. Right? So you need to have risk management. So a risk management plan. So this is an integral part of your project work. So when you submit your project work, we do expect what is your risk management plan. So in the research proposal, we also put under what are the risks associated in the execution of this project work. Now, without risk management, how? So risk management is part and parcel of the project. So if you join the company newly or if you are likely to leave in 3 months later, okay, you need to have some alternate plans. And you need to specify those things in the proposal. Okay, so please note that risk management is part and parcel of engineering. Yes, Chakaria?
I'm from the marine industry. Regarding
Marine.
marine industry,
Marine.
regarding bunker fuel. That means the flow meter, rate of flow for the supplying of fuel to the ship. Yeah.
So what is your day-to-day activities?
Because of they use air pressure, so most of the time they can't get the proper reading of the quantity of the oil.
Okay. The accuracy also.
Yeah,
problem.
correct.
So what are you going to do?
Right. To do something like
Regard.
that. Yeah.
How you can improve that? So you can have some jig or fixture so that for better reading.
Have to check a lot of getting the viscosity of the
How your competitor industries they do.
woman.
So can you plan something, some project proposal based on this?
That's right.
No alternative. All right.
I work in semicon equipment maker company.
Semiconductor.
Make the machine.
Where?
We build
Which
the
company?
VDL, ETG.
Okay.
I lead a team of like 10 people to build the machine.
So you can formulate a problem related to, because most of the time semicon is process improvement.
Build the machine. It does not.
You're dealing with the machines.
Yeah.
What type of machines?
Wafer, medical.
Are you dealing with the defects of wafers?
No.
Not
just
part
build
of
the
your
machine.
job? Manufacturing
Yeah,
process?
the machine
Only the machine. So if you want to improve the efficiency of the machine, can you do something?
There is beyond our control.
No, suppose if there's a robotic arm or anything, if there's a frequent failures, if you are doing any maintenance
We just give some, we just do repair for customer. They end customer like TSMC,
or
but
original manufacturers.
yeah,
So then what is the nature of your work?
manage the daily flow of the team.
So can you, okay, so basically this type of things, your current process, your management process, okay? So you can describe your current processes. Okay, it could be management processes, okay? It could be human interactions or it could be machine interactions, okay? It could be the workflow interactions. But how the workflow processes are going on currently. Now, can you identify any bottlenecks in that? So if there are any bottlenecks or if there is any scope where you can apply some engineering tools, so to improve the overall process. So to reduce the, so for example, lead time for a particular stuff. So if you want to reduce the lead time, so that can be okay, so mostly your problems will fall into the operations management side. So we need to look into the operations management. Now, our operations management is a huge topic. So there are thousands of students done operations management related topics as their project course. So you can look into those type of things. You can just browse, then you can formulate your problem.
Currently working for transport industry.
LTA.
So
LTA? LTA?
No, SMRT.
SMR.
Yeah. But I'm at the LRT side.
Okay.
Yeah. So basically, I'm more of desk bound now rather than on the call.
What do you mean?
Desk bound, as in I do mostly logistics.
Oh.
Yeah, stock. But currently our current problem is in the customer side of the ship. So the material used supposed to be the OEM said it's supposed to last for 5 to 8 years, but after 3 years we need to change. And then when we notice that it starts to drop down, and we know that the pushing of it starts to eat the pushing during the weight, and maybe the rough handling of the textures. So we are questioning my head lah is asking the engineers what's going on.
So what's going on?
Because it comes in a pack, it comes in a set. So when we do our maintenance, we change everything. So by OEM standards, it says to last for 8 years. But they didn't say to how many, what mileage the thing will go, at what elevation, how many angles, how many curves on the track. It just says 8 years. So we set our standard at 8 years, but it only lasts for 3 years. So management is asking, where is my 5 years?
Interesting. So they are right?
Yeah.
So the management is right.
Yeah.
So what the engineers say?
The engineers are they don't know how to answer.
Ah, so that means you have a problem, right? So that means you can do research on that. And this is a very good topic actually. Normally it can be done by a team of engineers. It's not done by one, so it requires a bit of testing, and also you can also do some online research. You find out a similar problem, because this is a worldwide problem, not only in your case. Okay, there could definitely, I think a lot of people must have done good amount of research on this, and they have their own findings. So you can read all those things and you can get some knowledge, then you can apply to your problem. So actually this type of things requires a bit passion. You need to be more passionate about these things, and then you need to spend a lot of time reading. But this type of things can be, because it's a practical one, right? And you may get some rewards from the management also in future. No, it's definitely it is something which needs investigation, thorough investigation. Probably you need help from different segments. So you can work on this type of problems.
So then why if you cannot solve before?
Second?
Why if you cannot solve before the semester end or what?
No. As I said, ultimately the solution is not important. I made it very clear at the beginning. So what is more important is that your demonstration, how whether your literature review is good or not, whether have you applied any good standard methodology or not, have you done any simulation or mathematical analysis or model analysis of the problem or not, whether your reporting is good or not. Okay, so there are other metrics, by which we can evaluate work. Final result is not important. It's important in the sense, we can define straightforward sometimes, If you achieve your objectives and the methodology is correct, you applied all the tools and techniques effectively. But you applied all those things, but you couldn't get the expected results, also good for the grades. Yes, yourself,
I work,
Kishin.
Michael.
Michael.
I work for Logitech lift company.
Lift.
Yeah, elevators. So I would say one of the current up and coming problems, because there are so many skyscrapers coming, right? A lot of tall buildings, more than 200 meters. So the issue is
More than
building.
200 meters.
In Dubai or
200 meters means 60 floors.
yeah. So
There are only few here.
here, let's say countries like Dubai, which is progressing more and more, there's an issue going on that building such a shaft for a lift and how to carry a lift with such high speeds. So there are a few problems that comes with this. Let's say with the speed, right? Speed limitations right now that we have, there's congestion for a lot of people. So too many people crowding, just waiting for few lifts down there. And also other issues would be
Those are all management issues.
management issues, but we can solve it through the design issues. I got a few design
Okay.
solutions.
Okay.
So there's also the part where sometimes the ropes they are not able to just handle that high of a shaft. So sometimes some buildings need to put 2 elevator shafts in just one building, and that's wasting space, wasting time for people.
So basically, you cannot because these are specific to a particular design or a particular height or a particular type of building. So we need to focus rather than generalize.
Okay,
So focus on a particular system, then identify the problems, then come out with a proposal.
because I do have a solution for high skyscrapers.
Yeah, you can still adapt certain solutions. But at the same time, the most important thing is you need to study the existing literature. So what are the current solutions available for such problems? And don't say no solutions. No,
No,
definitely there will be hundreds of solutions.
There are a few solutions where
So first you need to study those solutions, you need to weigh those solutions, then come out with your solution. So this is not for this course, but I'm telling you for project A and project B. For this course, only what is required is coming out with your proposal. But the problem has potential in continuing. Alright. Michael, and so all of you normally the deadlines you can't ask for extensions, so you need to be. You need to have clear plans. So normally extensions will not be approved. So if your assignments are okay, but this is a project work, so you need to plan your things. Alright. So
let's say I've got few design solutions in mind. Do I need to include everything in the proposal or?
First formulate and send, then we'll see. Because generally better to focus on 1 or 2 things rather than many. Because the depth should be there, not the breadth, but also the depth of the work.
Okay, but there is a specific issue with mine. So the higher it goes, right, the higher speed usually we need. So the vibrations is a major issue. So the higher the speed, the higher the vibrations are. So one of the solutions I was thinking of is maglev trains using magnetized. They are actually testing that right now in this. So I was thinking going into that kind of research.
Okay. You can also use, instead of the weights, counterweights, you can also use fluids.
Yeah.
So if you replace the counterweights with fluids, actually the vibration can be minimized. So there are many techniques. But again, the factor, the cost factor, always any manufacturer, they want to reduce the cost. So it is always a balance between the cost and the technology.
But But okay, does it matter if, let's say, I mean, everything we do, there's pros and cons, right? So, like, does it matter if the pros like need to heavily outweigh the cons, or is it like just another?
No, what is required is application of your knowledge. So it's very simple on that. Whether what you do is correct or not wrong, we are not going to judge. So we are going to judge whether you have applied the right tools and techniques, whether you have demonstrated some knowledge, whether you've done a good literature review, those things.
Then do you recommend any simulation softwares for this kind of?
Oh, this will, simulation software and other things will be part A and part B.
Oh, okay. So you don't need to do that for right now.
You need to identify, if you identify, that's good.
Okay.
Go ahead.
I'm in the welding industry, so basically I sell welding machines and consumables.
So people are still doing welding.
Yeah.
So what type of welding?
MIG welding, but now it's more into automation.
Mm-hmm.
So with automation, the only issue is probably parts. Since it's relatively new parts that damage quite easily.
Mm-hmm. So,
Haven't really thought of the bigger ones.
you're thinking something related to the welding related issues. Okay. So you can also study some materials properties. Any specific problems related to particular type of welding? Because there are many welding tools, right? So you can study the relative advantages, disadvantages, and identify particular, depending on your scenarios. Possible. Okay. So again, all of you make sure that you follow the deadlines. That's very important. Yes.
I'm a project engineer. I'm doing data testing for data centers, hotels, office spaces, pulling of the actual data tables. So what I do is mostly like just management, the risk assessment, safety and stuff, and going to site make sure the work gets done. So for problem wise, I don't know what problem I can have besides the client being stupid. Yeah.
So you can think of designing a particular mechanical system for a, let us say, particular type of a data center. It can be mechanical, air conditioning related, or it can be just hypothetical setting up, or you can also study relative mechanical settings of, identify different type of data centers. So you can also study how the mechanical systems can change.
Because my side is mostly just the data cables itself. So the way we lay is by like physically pulling it.
No, you can extend a bit more into that, because if you are doing a routine job, let us say, where there is no scope for you to apply, what you studied, you can still, relate that particular problem to other issues and you need to formulate. Yeah, you need to think about something related to that. Yeah. Now, let us say if you're you're planning to move your job, or you want to, get promoted into that. So, what will be your future responsibilities? And you can also prepare something related to your future responsibilities. If you get elevated in the job.
Even in my past experiences, because I did 2 years at maintenance in a factory before, so if I do something from that side, it should be okay.
Oh, okay, that is also fine, but
I don't have anyone to consult.
Huh?
I don't have like anyone to consult or what, because it's a bigger job.
No, you can also choose some problems which are theoretical, which are based on conceptual developments. So not real, but only on concept. So concept means you can come out with engineering ideas, engineering drawings, engineering sketches. You can apply the basic engineering laws whether a particular design can work or not, and also use some simulation techniques. Yeah, if you don't find readily, so you have to relate to maybe your previous experience. Yeah. All right. Yes.
maintenance engineer,
Semicon. Mostly troubleshooting, day-to-day operations, day-to-day working, troubleshooting of some systems.
我不懂。
So you can formulate something related to that, some problems. You can also do that, yeah.
I mean, 我会的，我会啊，我不会。
No, basically you must, all of you must come out with a proposal. So you need to identify a problem, then some background analysis of the problem. So that is the first part of your assignment. So the second part will be the literature. Yep.
We have a servicing technician for lapping machine and polishing machine.
Typing machine.
Lapping.
我那边通常 solve 得了啊，都是 one to one replacement。solve 不了的东西就是我没有做，没有 solve 不了。
So there is any impact scope for you to come out with a problem, proposal?
Then 又不会太太难的东西就叫别人做，容易的东西也是叫别人做。对，
Okay.
现在更惨，现在真要拿 plan 的东西来给他，我的 plan 全部倒了，拿不到给他。
Quite rough. For example, for the barrier, for the part, maybe 1 micron.
我们 document 收到，我们的 document 收到很差。
Okay, so if you have anything, where you can improve by designing a jig or a fixture or some related, equipment, those are good problems actually. So you can improve the performance of anything by adding up something. So it may not come from original equipment manufacturers, but you can also design. For example, this is a cup. So if you can come out with a coaster, so that can be a design. So suppose you are lifting weights. So if you can come out with a system where there is no human involved, where so people, one person can do it, or you can totally avoid, you can do with the help of a small crane. So we design the crane, that can be a problem. There is no need for you to manufacture and test, but you can do this using simulations. So we need to think about this. Okay.
I am a more designer, working for the ASMP.
Working for?
ASMP.
What is that?
The company name.
The full form.
Full form.
Full form.
The ASM Pacific Technology.
What do you do?
My engineering responsible for the fully drawing and 3D models.
Okay. So?
Sometimes also join the manufacturing department to make some manufacturing process.
So you can come out with a proposal based on your work. Think about it. All right. Okay.
Currently in the Singapore Armed Force.
Oh, you are still an S. Okay.
Don't have any experience, so not quite sure of what problem.
So when will be your word? Oh, you're full time?
No. Do NS.
Oh, when you will be completing?
A few more weeks.
So you're going to join some company?
Still thinking.
Okay. So, but you can think of some engineering problems, some general problems. Okay. So Takashi, sir?
Working in the aviation company, mainly deal with hydraulics.
Okay.
So hydraulics like landing gears, pumps, engine pumps and stuff.
So
Problems I face at works are like high torque, cross integration stuff. Some of them have a high torque value. So fixture wise, how we going? Currently we have a current fixture, but mainly because of we are using gear ratios to achieve high torque value. So one of them deformed. So maybe can think of that as a problem.
So you can think of designing a fixture for
Designing a
some
fixture.
table or something.
Or else will be something to do with hydraulics.
Okay.
Like high pressure,
Yeah.
any prevention costs in
So-
case of like hose burst.
You can come out with a problem like that. Yes, Gauri? Yes.
Residential visit, I was quite intrigued by how in one of the labs we saw some parts in the human body was replaced with something they made, engineers made. So I would like to look into that.
You mean the,
Or like hip replacements.
okay, heart faces or other things?
Stents.
Stems. You need to think of something where there is a scope for you to do a good literature review and a scope for you to apply some engineering tools and techniques. So think on those lines. And so basically you'll be working on conceptual designs only. So you're not going to come out with a prototype or test. Okay? So think on where there is a scope for you to apply some engineering knowledge.
Just basically design.
Yeah.
What about materials?
Of course, material properties also. Material properties also. Yes, the last three, then we can go for a break.
Alright.
Yes. I can't hear.
Working as a associate in
Semicon, okay.
basically I'm doing something like laser manufacturing. So talking about laser manufacturing. So on the flow meters. So this kind of is like how to the lifetime is really easy to use from any type of contamination. That's why I'm very small. Human body, moisture, whatever metals, organic compounds, everything. It can really affect the product, lifetime of product.
So what is the problem?
The problem everything we are facing is how do we control the moisture?
Okay.
So we control humidity sensor, testing brightness.
Yeah, so you can, I think definitely you can come out with a good proposal. Alright, next. So, not directly relevant to engineering.
But for my past experience in the previous job was working in school. So it's much more teaching the students on mechanics of the renewable as a line of airborne stuff like this. So I might improve in that area.
Maybe you can think of designing a renewable energy system for a particular setup. Yeah.
I work as a regional head for service engineer for Singapore Fixed Robotics.
Okay.
So our company is mainly based on autonomous cleaning robots. So we have a lot of problems. For example, we got issues with scale because most of our robots uses a lot of human workers to put together. So that's one. Then the other one is training problems. Robots able to do the job, get point A to point B, but it's not optimal. So
So improving your process, yeah. So come up with the proposal. All right, guys. So now 8:46. So you can go for break. So 9:05. After that, I will be showing you some of the proposals and what is expected for the